Sometimes it is necessary to move the files that make up your database. Careful consideration of how to move these files is critical to ensure that you retain the data and the operation of the database after the move. There's a couple of considerations. We can move user databases, or we can move system databases. Obviously, moving the user databases is a little simpler because it doesn't mess with the SQL Server system databases and their locations. Some of the reasons you might have for moving your database files perhaps might be a failure recovery. So we might have had a server failure or a hard drive failure, and we need to move to a new server. You might have to do a system or database relocation for other reasons, such as the hard disk filling up. Or perhaps you're going to run scheduled maintenance on a system, and you don't want the database to be taken down, so you can move your database to another server. The types of objects we can move are the data and log files, and any full-text catalog files that we might have as well. We can use the alter database transact SQL statement, specifying a new file name and a location if we're on the same instance. Moving to another instance or another server requires typically a backup and restore or a detach and attach operation. A couple of little caveats. If we're moving the database to another server or another instance of SQL Server, it may require the recreation of metadata, and this is typically in the form of logons, or it might be in the form of other functions or different aspects that we have available. We should also verify the logins and permissions when we're ready to move the system or move the database over, because we want to make sure that we have the correct logins and the correct permissions on the destination source of where we're moving the database. So let's go ahead and take a look at how we can move a database using SQL Server. In this case, what we're going to do is we're going to move the AdventureWorks 2014 database. And we'll paint the scenario that we didn't follow good practices and we put the AdventureWorks on the system drive. And in actuality, when we did the installing the database video, that's precisely what we did. We put AdventureWorks on the local system drive. Now we want to move it so that we can free up space on the system drive, and we're going to put it on a data drive. The way that I prefer to move a database that is already existing on a system is to right-click, go to Tasks, and take my database offline first. Choosing OK will take my database offline, and it will halt any current connections and prevent any new connections from taking place on that database. Okay, now that our AdventureWorks database has actually been taken offline, we can perform another task, which is known as detach. So when we detach a database, essentially what it does is it removes it from the SQL Server instance. So we no longer see it listed in SQL Server. Now what we're going to do is we're going to step out and we're going to move the database to a different folder. I've created one called Data on my D drive, and I'm going to select my AdventureWorks log file and data file. And now we're going to move the AdventureWorks data and log file over to the new data drive. Now that the files are here, they're no longer in our original directory, which was on the system drive. So we will minimize these and come back into SQL Server, right-click the Databases folder, choose Attach. Under the Databases to attach, we need to click the Add button, and we need to go and find our data on the D drive. So again, we've put it in the D data folder. Notice that we only see the MDF file, so the actual data file for AdventureWorks. But when we highlight it and choose OK, SQL Server is smart enough to know that there is also a log file attached to it, so it includes the data file and the log file in the database details. So when we click OK, SQL Server attaches our database, and we now see AdventureWorks 2014 has been included in our SQL Server instance. And just to verify, if I right-click and choose Properties, and we take a look at the database, we can see that our database has been restored with all of the necessary information that was there before. And if we take a look at the files, we can see that they now exist on the D drive in the data folder for both the MDF and the LDF log file. Ensuring data integrity partly falls on the database administrator, but also on developers who are accessing and consuming the data. But what is data integrity? Well, I like to think of it as data that has been validated against a set of criteria to ensure that it is correct, error-free, and applicable to the usage required. Enforcing data integrity guarantees the quality of the data in your database, and it helps to ensure that the data you have is actually valid for the use that you intended. As an example, if we think about an employee table and we have an employee entry with a specific ID value, let's say 49576, well, the database shouldn't permit another employee to be entered or to exist in that database with that same ID value. This would be a violation of some form of data integrity. Likewise, you might have a rating column for a specific piece of data that has a range. Say, valid values are only from 1 to 5. So you would want to put a constraint or some type of integrity check on the data to verify that those values would not be outside of that range. Data integrity has 4 different categories. And to take a look at what those categories are, let's step out and take a look at a TechNet resource. So data integrity can be classified as either entity integrity, domain integrity, referential integrity, or a user-defined integrity. On this page, you'll see an explanation of each one of these different types of integrities that you can apply or enforce on your SQL Server instance. Some of the enforcement options that we can use are things such as primary key and foreign key constraints on tables, unique constraints, which help us ensure that values are unique within the database, check constraints, which help us to enforce different data validation mechanisms, default definitions for values that are not assigned something, and whether we allow null values or not within certain fields. One discussion that we've often had in the past is around, do we allow null values for things such as cell phone numbers? So a customer might not even have a cell phone. So do we enter a 0 value or do we allow a null value for that? And those are important considerations for how your data is handled within the database. Let's step out into SQL Server Management Studio real quick and have a look at some of these constraints in an actual database. So if we expand our databases folder and take a look at the AdventureWorks 2014 sample database we've been using throughout this course, we can expand our tables and then take a look at some of the constraints that have been placed on some of the tables here. Expanding Human Resources Employee table, we can see the Constraints folder. And as we expand the Constraints folder, we can see a number of constraints that are placed within this database table. So let's take a look at a sample constraint. If we double-click and open the Check Employee Gender constraint, we can see that it pops open a dialog box and allows us to look at the expression that dictates what's taking place. So in other words, what we're attempting to do here is be very consistent in the values that are entered for the gender of the employees. We want them to be an uppercase F for the female and an uppercase M for the male. The description says that we're creating a gender check constraint. In this case, we're checking for a lowercase f or a lowercase m or an uppercase F or an uppercase M. And our expression is what will do the data conversion for us automatically. So that's a quick example of what's known as a check constraint. So let's take a look at another type of constraint, in this case a default constraint. I'm going to actually bring this up in a query editor window so that we can see the text that's actually being used to create this default constraint. Note that you'll typically create default constraints as transact SQL statements. Up at the top, we have an alter table statement, and we're dealing with the Human Resources Employee table. And we're using an add constraint statement, and we're affecting the employee vacation hours table. We're setting a default value of 0 for the vacation hours. And the reason that we're doing this is just to say if a new employee is created, we want to default the vacation hours to 0 in the event that nobody enters anything into that column. So that's an example of check constraints and default constraints. Some of the other ones that we noticed on our table were primary key and foreign key, and those are actually factored into the keys folder. So we can see a primary key and a foreign key in the employee table. Understanding how the primary key and foreign keys interact with the different tables helps you to understand the referential integrity within your database. So a primary key is typically set up as a data type that does not allow nulls and will be unique, and this helps to ensure that this ID is unique across all of the entries in that table. And the foreign key relationship allows us to relate this to a person table within the database, and it provides that connection between those two tables. So again, we've taken a look at some of the different constraints that we can put into the table. We've looked at a default, and we've looked at a check constraint, and we've also taken a look at some primary key and foreign key constraints in the form of keys on our database table. In this video, we'll discuss the purpose and use of indexes in a SQL Server database. An index is essentially an on-disk structure that is associated with a table or a view, and it helps to speed the retrieval of rows from that table or view. In order to do so, it contains keys that are built from typically one or more columns within the table or the view itself. Now, these keys are stored in a structure, typically a B tree, that enables SQL Server to actually find the rows and associated data with the keys quickly and efficiently. Now, SQL Server supports a few different types of indexes, so let's take a look at those. Looking in the MSDN page for the indexes for SQL Server 2016, we can see a number of indexes that are available, such as the hash, clustered, non-clustered, unique, and column store. Typically, you'll spend your time focused on creating clustered and non-clustered indexes. So read through these descriptions to get an understanding of how these types of indexes are used within a database. Some of the advantages of using indexes in your database: they help to reduce the I/O operations on the disk. Because we're able to find the results much quicker, then we reduce the I/O operations that need to be performed to retrieve that data. They also consume fewer resources through improved query performance. And you'll find them helpful in select, update, delete, or merge statements that are being executed against the database. Let's take a look at some indexes that we have in a SQL Server database already. So using our AdventureWorks 2014 database, if we expand the Tables folder and take a look at our Human Resources Employee table, expanding it, we'll see an indexes folder, and if we expand that, we can see the different indexes that are available. Simply hovering your mouse over an index will give you a quick idea of the type that it is, and we can see that the organization node is actually a non-unique and non-clustered. We can also double-click on one, and it will pop open our index property dialog box. Now, this one has already been created on the employee table. It's been given an index name of PK_employee_business entity ID, and it is a clustered index and also specified as unique. And note that the index key column is entered as the business entity ID with some very specific columns, such as sort order, the data type, its size, etc. If you need to create a new index on a table, simply right-clicking the indexes folder and choosing New Index will provide the available options or the types of indexes that you can create. If we choose a non-clustered index, again, it automatically selects the employee table name, and it asks us to give it a non-clustered index name. So in this case, we don't necessarily want to leave the default, but it's going to depend entirely on the column that we're going to access. So we noticed before that we used a primary key or a PK as the beginning, and this just basically described the type of index that we were creating and using on a column name. So if we're not sure of what we want to give the index for a name, we can come down and add our index key column first. Clicking the Add button provides all of the necessary columns that are available in that table. So these are ones that we can actually choose to make our index on this table. Now, we don't want to just randomly select a value, such as a job title or a birth date, because these are not necessarily going to be unique values. But using the example as before, the business entity ID we know was a unique value in the database, so it's a good candidate. We can also select multiple columns to combine the values across them to make a more unique value and to increase the efficiency of our index. But in this case, let's stick with our business entity ID and choose OK. And because we know that it was a primary key, we can use the PK underscore as the prefix on this, and then we can call it business entity ID, or you can simply use another name, and in this case, we'll just call it PK underscore. We know that it's a business entity ID, and so I'm just going to create a very unique and short name. The index type is already non-clustered, and that was chosen when we created the new index, and then we can make it unique as well if we choose. And once we select that, Those are the basic options that we really need to worry about. We're not going to go into some of the more advanced options over here. That's for an advanced course on creating indexes, but we'll just simply choose OK. And we now have a new non-clustered unique index created in our database. In this video, we'll discuss the purpose of database replication and show you how you can accomplish it in SQL Server. So what is replication? Well, essentially, it's a set of technologies for copying and distributing data and database objects from one database to another, and then synchronizing between those databases to help maintain consistency of the data. Using replication, you can distribute data to different locations and even to remote or mobile users over local and wide area networks, dial-up connections, wireless connections, or even the internet. There are three basic types of replication. The first is transactional replication, and this is typically used in a server-to-server scenario that requires high throughput, including improving scalability and availability, and it's potentially used for data warehousing and reporting scenarios as well. It's great for integrating data from multiple sites or integrating heterogeneous data and offloading batch processing. The second type of replication is merge replication. This is primarily designed for mobile applications or distributed server applications that have possible data conflicts. Common scenarios include exchanging data with mobile users, such as consumer point-of-sale applications and integration of data from multiple sites. And finally, there's snapshot replication, which is the one that we'll demonstrate. It's used to provide an initial set of data for your transactional or merge replication. It can also be used when complete refreshes of data are appropriate. So let's step out into SQL Server and see how we can create a snapshot replication. Here we're going to make use of the AdventureWorks database, and we're going to create a publication to replicate a table in that database. As we expand the replication folder, we see local publications. Some of the terminology that we need to understand is that in replication scenarios, there is a publisher and a subscriber. The publisher creates the initial data publication of which subscribers can subscribe to and either pull or receive push data. Right-click Local Publications and select New Publication to start the wizard. Select Next on the Welcome screen, and we get to choose our database. So we have a publication database option for each database that we have available on our server. We're going to choose AdventureWorks and click Next. Now, we talked about the three different types of replication. There are also four different types of publications: a snapshot publication, a transactional publication, peer-to-peer, and a merge publication. You can read through each of the descriptions to gain an understanding of what each type of publication will be. We're going to create a snapshot publication. And in this case, what we're going to do is select an individual table from this database. So as we scroll through the information, we can see all of the tables that are listed from our AdventureWorks database. In this case, what we want to do is find our product table. We're just going to replicate the information from product. Now, if you're a keen observer, you might note that we should also be including some other tables, such as the product category, product description, etc. We're just going to keep this publication simple for now. We're not going to worry about the related tables. So let's click Next. This screen allows us to apply a filter if we want to for specific table rows. Applying the filter, you would have to click the Add button, and then it will generate a filter statement for you by you selecting the different columns that you want. We're going to leave the default and basically take the entire table. So clicking Next, we now have some options for the snapshot agent. And in this case, we want to create a snapshot immediately and keep it available to initialize the subscriptions. However, we can also choose to schedule a snapshot agent to run at different times. Selecting that checkbox and clicking the Change button allows you to configure a schedule for that. We'll create our snapshot immediately. Clicking Next, we now have the Agent Security dialog box. We need to select Security Settings and choose a Snapshot Agent Security context in order for this to run under. Now, the recommendation is not to use a SQL Server agent, but to avoid confusion and any kind of issues with Windows accounts across the different servers that we're working with, I'm just going to demo running under the SQL Server Agent Service account right now. Again, it's not recommended as a security best practice, but we're just going to utilize it for the purpose of this demonstration. Once I click OK, we now have our security settings in place. Clicking Next brings us to one final screen where it talks about wizard actions, what happens when we finished. We want to create the publication. If we wanted to only create a SQL script to deal with the steps that would create the publication later, we could also do that here. Clicking on Next will give us the summary screen, and we have to provide this publication a name so that it's easier to find. And in this case, we're going to do an ADV_works, so we know it's coming from the AdventureWorks database, and we're just simply going to call it products because that is the table that we're going to replicate. Once we've named it, we can click on Finish, and we will get all of our success messages with any luck, assuming that nothing goes wrong. And clicking Close, we now have our publication available. If you expand local publication, you can actually see all of the different publications that are available. And here's our new AdventureWorks products publication. Now that we have that created, let's go ahead and look at creating a subscriber to then gain access to this. So we'll switch over to our virtual machine, and our virtual machine is also running an instance of SQL Server. And in this case, we will expand our replication folder, and we want this to be the subscriber. So let's right-click and choose New Subscriptions. Click Next on the Welcome screen. So in this screen, we get to choose our publisher. It defaults to the local SQL instance, but we want to go out and find another SQL Server publisher. In this case, we're going to use our other PC, which is the publisher. You can also select the Browse for More in the network servers to actually go out and find another server that might exist on your network. It will go ahead and retrieve the data and look for all of the different SQL Server instances that it can find, and you simply need to select the option for the server that you want to use. We click our Connect to connect to it, and once we do that, we now see the available published subscription that exists on that server. It's automatically highlighted, so let's just click on Next to accept that as the default for the one that we want to use. Now, how do we want to run our subscription? And in this instance, it's asking us if we want to create this wizard to run all agents at the distributor, so in other words, it will be a push subscription, or do we want to run each agent at its subscriber, in this case, a pull subscription? And it defaults to choosing the pull subscription, and it says that it reduces our processing overhead at the distributor. And so you get to choose whether you want to have the publisher control this replication or the subscriber control the replication. Let's go ahead and leave the default for the time being and click on Next. And now what it's going to ask us is, we already have our subscriber in place. Where do we want to store this? We need a subscription database. This is where you can actually say, I need to create a new database, or you can have an existing database already in place. If we choose a new database, then it pops open the new database wizard, and we can simply go ahead and create a new database for this, and we'll call this ADV Works and Products, because that's what we're actually going to be storing in this database. And we can leave the remaining information as is default for now, because we know that this will grow automatically and unlimited if the data coming in exceeds the size that we want. So let's just go ahead and choose OK for creating the new database. It does that, and we are ready for our next step. When we click on Next, we have to provide an agent security. So we will select the ellipsis button. And again, we could specify a Windows account, but we're just going to run it under the local SQL Server agent for this demo. Choose OK, and click the Next button. And then we get to choose the synchronization schedule. So we can have it run continuously, run on demand only, or we can define a schedule. Let's leave it run continuously. Click on Next. And then the initialize subscriptions, this one here specifies whether we want to initialize each subscription with a snapshot of the publication data and the schema. And we can choose whether we want this to be memory optimized or not, initialized, and when. In this case, we want to say immediately. We could choose at first synchronization, but let's go ahead and run it immediately. Click on Next. And at the end of the wizard, what do we want to have happen? Well, let's create the subscription. We're not going to worry about generating a script. Clicking on Next. We have the summary screen from the wizard, and when we click on Finish, the wizard will go ahead and create the subscription, contacting the publishing database, and we get our success messages. We click on Close, and here's our new subscription. Also, if we go into our databases folder, we can see that we have our AdventureWorks products database. So that's a quick demonstration of how to create a publish and subscribe model for replication within SQL Server. The transaction log in a SQL installation is an important file. Recall that your transactions in the database, such as updates, inserts, and deletes, are written to the transaction log first and then to the tables when the database engine determines it is a good time to do so. Log shipping offers the following advantages. It provides a disaster recovery solution, and it supports limited read-only access to secondary databases during the interval between restore jobs. And it also provides for setting a delay between when the primary server log backup and secondary servers restore. Why would we use log shipping? Well, we can automatically send log backups to a secondary server if that's what we decide to do. It preserves those transaction logs for recovery later on. We can also set up a monitoring server. And this is a third server instance that acts as a monitor server and can actually record the history and status of the backups and the restores as they take place. The monitor server can also raise alerts if the operation should happen to fail. The three main operations are backing up your transaction log on the primary server, copying that log to a secondary server instance, and restoring the backup on the secondary server instance. Let's take a quick look at how to configure log shipping on a primary server. In order to do so, we open SQL Server Management Studio and find the database that we want to use for log shipping. In this case, we'll use AdventureWorks. Right-clicking and choosing Properties opens the Database Properties window where we find Transaction Log Shipping. Here, we can enable this as a primary database in a log shipping configuration. Clicking Backup Settings allows us to specify a network path for a backup folder, and in this case, this could be one as simple as a network share that we have already created. So the network path to our folder where we have the backup stored can be put in. Also, if we're dealing with a local backup, so we might have something stored on our local hard drive, and we can actually have that set up as well as a database backup or a log backup or what have you. We can put this in here as well. Note the caution here that you must grant read and write permissions on this folder to the service account for SQL Server to ensure that it has permissions to actually write to that folder. We can specify things such as deleting files that are older than so many hours, and we can also send an alert if no backup occurs within a certain time frame. So this is determined based on our scheduling for the backup of the transaction log. We'll create a backup job, and the job name, the default, is ls_backup_AdventureWorks. So it's just ls meaning log ship, and then it's a backup, and it's of the AdventureWorks database. You can click the Schedule button, and then you can configure the schedule to be recurring, and this is a standard new job schedule from SQL Server. And then the summary of what your schedule will be shows up here in the schedule box. We can choose to compress the log file backup if we wish. And once we've selected the options here, we can click OK. Now that we're back into our database properties for the transaction log shipping, this is where we can add a secondary database, and we'll do that in a moment. But I also wanted to point out if we had a third instance, we could use it as a monitor server. We're not going to demonstrate that here because it requires a third server in the configuration. So under secondary databases, let's click the Add button and then choose Connect. And then in this instance, I'm going to just do a log shipping on my same SQL Server instance that I have, but I will store it in a different database. So when I connect to that SQL Server, it will ask me where I want to put my secondary database. And in this case, I want to use one that I can have for transaction log shipping. So I've created one earlier called adv_works_tl for transaction log shipping. When we initialize our secondary database, we can choose a couple of different options. We can generate a full backup of the primary database and restore it into the secondary database and create the secondary database if it doesn't exist. And then there are various restore options, such as the folder for the data file and the folder for the log file. You can also choose to restore an existing backup of the primary database into the secondary database and create the second one if it doesn't exist. I'm just going to select this option that says, no, the secondary database is already initialized. So in other words, we had created it, it's initialized, and it's ready to go. The Copy Files tab is where you would put a destination folder for copied files. Typically, this would be located on your secondary server. I'm not going to put that in here because primarily it's used for a secondary server that might be on the network someplace else. And then files are restored from the destination folder on the secondary server instance, and we can choose how to do the restore transaction log. The database state should be put in no recovery mode or standby mode, depending on the option that you choose here. and we can delay the restoring backups for a specific number of minutes and also send an alert if no restores have occurred. Again, we get a restore job name and a schedule that goes along with it. For the backup, I'm actually going to put in d:// and I have a db_backup folder that will allow me to actually store it on the secondary server as well. Once again, normally this would be on a network server, but we can also store it on our local server instance as well. So let's click the OK button, and now we see that we have our server instance and our database configured here. We are ready to click the OK button, and then we see that it has saved a secondary destination configuration, and it has saved the primary backup set, and now our transaction log shipping has been completed. In this video, we'll discuss database mirroring. A word of caution before we continue. Microsoft has indicated that this feature will be removed in future versions. Their recommendation is to use always-on availability groups instead. We'll take a brief look at always-on availability groups in a later video. So what is mirroring? Essentially, it's a solution that allows you to increase the availability of a database. It's implemented on a per-database basis, and it only works with databases that are set up with the full recovery model. Some of the benefits of working with database mirroring are that it increases the availability of a database. It also helps to increase data protection, and it improves the availability of a production database during upgrades. Essentially, you have the ability to take a production database offline, switching over to the mirrored version of that database, and allow users to continue accessing the data as if nothing had happened. In terms of implementing it, we deal with a principal server, a mirror server, and a witness. These must be hosted on separate server instances. Ideally, each instance is also hosted on a separate host system. Each instance will require a database mirroring endpoint, and these endpoints must be accessible to all other instances. In terms of authentication, you must ensure that the logins that exist on the mirror server are also present on the primary server. Also, you need to ensure that the metadata from the primary server is present on the mirror server, so that we ensure that we have a duplicate environment not only for the data, but also for authentication and the metadata as well. This ensures compatibility and completeness of the mirror. Again, it's important to note that Microsoft will be discontinuing support for mirroring in future database products. As a result, if you step out to the MSDN article on setting up a database mirroring, you can find all of the necessary steps to prepare your database mirroring solution. We're not going to demo it in here because of the fact that this will be removed in future versions, but feel free to use database mirroring in the meantime if you so choose. The two main availability options that SQL Server 2016 supports, and that will be used in place of mirroring, are always-on failover clustering and always-on availability groups. We'll discuss the availability groups option in this video. The always-on groups is intended to replace the legacy mirroring technology. Always-on maximizes the availability of a set of user databases, typically for an enterprise. An availability group supports a failover environment for a discrete set of user databases, and those are typically known as availability databases. And these will fail over together. An availability group supports a set of read-write primary databases and 1 to 8 sets of secondary databases. Optionally, secondary databases can be made available for read-only access and/or for some background operations. To support always-on availability groups, a server instance must reside in a node on the WSFC failover cluster hosting the availability group. So this is a Windows Server failover cluster. It must be always-on availability groups enabled, and it must possess a mirroring endpoint. Now, we don't have a Windows clustering environment set up for this demo, so if we step out into SQL Server, we will see that some of the requirements are not specifically met. For example, if we select the always-on high availability, we see that it is not currently enabled. In order to enable it, we would actually have to be in the SQL Server Configuration Manager under the SQL Server Services option, right-clicking the instance service and choosing Properties. We see the Always-On High Availability option tab. Selecting that, it will immediately tell us that we are missing some of the requirements. So this feature requires a non-WoW environment or an x64 Enterprise Edition of SQL Server 2012 or later. We have SQL Server 2016 Enterprise. However, we are not running on a Windows Server 2008 or later environment, and it is not a Windows Server clustered environment with the appropriate hotfixes installed. So again, you'll need to configure a clustered environment. You'll need to be using Windows Server 2008 or later and SQL Server 2012 or later in order to configure the always-on high availability. So now that you have your SQL Server installed, the database system is up and running, and you know how to create user accounts and logins, what's next? What do we take a look at to get the most out of our SQL Server information? Well, if you wish, you can take a run over and take a look at our course, Relational Database Fundamentals, which will provide you with a great opportunity to understand how you might want to create relational databases and how to work with different data anomalies in gathering requirements. If you want to also pass the Microsoft Exam 98-364, take a look at our other course, Database Fundamentals on Storage. And finally, if you want to dig in deeper to SQL Server, TechNet has a ton of information on the Microsoft SQL Server library page. So now that SQL is installed and you know where to find more information, let's go start creating databases on SQL Server 2016.